Mashallah, we going to do our second lessons today. It's on state of matter. Okay, this is a topic which will affect all the other topics, because any substance you deal with, it is either one of the state of matter. Okay, it's either solid or liquid or gas. Within the liquid, we have aqueous solution also, okay? And we have molten solution, okay? Aqueous and molten, yes? Aqueous means some water, molten no water, okay? If there's water, it will evaporate. Now, the state of matter. Before you ask yourself, what are the state of matter? Ask yourself first, what is matter? Okay? What is matter? What is matter? What is matter? Okay? Who knows what a matter is?
Everything.
Not everything. Everything. That is not the intelligent definition. That's not a chemistry definition. What is matter?
Matter, what is made up of everything, like substance.
Still, that is not an intelligent definition. What is matter? Matter is anything that has mass and occupy space. Occupy a space. So if that is the case, most likely it consists of everything you can think of. We can say everything is made of matter. Yes? Everything is made of matter. Okay? Have you ever heard the word dark matter?
Yeah.
What's dark matter?
This stuff is in space.
It's called anti. You have heard of these things: antimatter, dark matter, and black holes. Black holes, yes? Go and look at these things, yes? Because I can explain all these things, that we don't have time for that, okay? Look at dark matter, antimatter, and black holes, yes? So matter is anything that have space, that occupies space, and it has mass, okay? That is what we call matter. Now the state of matter. All these things you see in the universe, let me say in the universe, or the creation of Allah subhanahu wa ta'ala. Now, when you say the universe, remember, we're talking about the first heaven. What is within the first heaven? That's what we call the universe. And the universe, not even 4% of it has been explored. Okay, so how big is it? There are billions and billions and billions of galaxies. Our own galaxy is called the Milky Way. Have you heard about that? Our own galaxy is called the Milky Way. And there are billions and billions of galaxies within the first heavens alone. Sama' dunya. In Arabic, they call it Sama'u dunya. Allahu alladhi khalaqa sab'a samawati wal arda tibaqa. Well, you have that in the Quran, okay? A lot of it in the Quran. Allahu alladhi khalaqa samawati wal arda fi sittati ayyamin summa stawa al arsh. Okay, all these things. The Sama' dunya is what we call the universe, okay? Matter exists in 3 states, okay? Matter exists in 3 states. So exam questions use the right word. Yes, it exists in 3 states. State means a condition, okay? State means a condition. The condition in which it appears, yes? And they are solid, okay? Liquid and gas. Now, to understand this concept, solid always will have a physical presence in it. Physical presence. So you can feel and touch it. You can feel and touch, and you can see. Okay? You will see this in the textbooks. But basically, this is common sense. Okay? This is a solid. You can touch it, you can feel it, you can see it. But can you see gas? You can see some gases, but you can see not all gases. The atmosphere consists of what gases?
Oxygen.
You should know this stuff, you know. The atmosphere consists of O2,
And nitrogen.
nitrogen,
And carbon dioxide.
carbon dioxide, and other sub. Okay, that's right. So solid, you can see the physical presence. You can see, feel, and touch it. Okay, it has high density. In this, they have high density. Compared to, high density compared to liquid and gas. Okay, you can, like this, density, yes? You can, okay? Yes. So, and the particles, yes.
Close together.
Particles are compact, compressed, or very little space, okay? Very little space, yes? And they may have dimension in it. They may have dimension. You will see in the textbooks, but dimension means length and breadth, okay? Sometimes the other one, length, breadth, and height, okay? Solids, yes? Yeah, you can measure all these things about solids, okay? And solids, can I write this? There's too much noise. They will have high boiling point, isn't it? Yes, high boiling point, and even higher melting point. Yes, high melting point. Yes, because they become, when they melt, they become liquid. Yes, melting point. Not high melting point. Yes, boiling point. I can say there are some metals which are in some semi-liquid form. Okay, and then we could talk about their boiling point. Yes, so let us look at how a solid look like. It will be many particles, yes? Let's say sodium, let's say a bar of sodium. Okay, so you can see it has shape in it. Okay, it has shape, it has its own distinct shape in it. It has its own distinct shape in it. It's distinct shape. Identifiable shape. Okay, and you can see the particles are stationary. Isn't it? The particles are stationary, meaning they are not jumping about, isn't it? Okay, and they have a form. You can see they have form in it. They have a form. Okay, so therefore, if that is the case, what do you think about the electrostatic forces? So if electrostatic forces, that is the forces between the particles, yes? So if it has shape, okay, you can feel and touch, that means a higher strength is bonding the particles together, in it. That's right. That's why they will have a higher boiling point compared to liquid and gas. Okay? The electrostatic forces between the particles in a solid are very, very strong. Okay? So you can have electrostatic force very strong. Do the particles do the particles move about?
It vibrates.
No, they don't move about.
It don't move, it vibrates.
Yes, okay, but it vibrates, yes, but it don't hardly move about. Okay, hardly mobile. The particles are hardly mobile. Hardly mobile. Because so much energy is stored in them. Yes, energy stored in them. Okay? So much energy stored in them, kinetic energy. Okay? You can see how compact they are. Okay? But liquid, on the other hand, will have particles but a bit far from each other. Okay? Okay?
Spacious.
Yes. So therefore, liquid, okay, they don't have a form. No form, yes? They don't have form. They don't have form. Let me do that with a black pen, okay? I don't know what happened to my red one. They don't have foam. They don't have foam. So therefore they take the form of the container. They take the form of the container in which they are. So if I have a liquid, I put it in container, the form of the liquid will be the container itself. Yes? If you have a container like this, the form of the liquid will be like that in it. If I have a container like this, the form of liquid will be take the form of the container. Yes? If I have a container like this, the form of liquid will be the container. It's it. But unlike the solid, you can see it, you can feel and touch. This one you can see, you can feel, yet still it doesn't have a form in it. It takes the form of the container. Yes, it has mass. Yes, because you can measure it in it. Yes, it has mass, you can measure it. Yes, so therefore the particles have space between them. Yes, a bit apart. Yes, particle has between them. Therefore they can move. Yes, they can move. Okay, once energy is applied, energy will cause vibration and movement of the particle in liquid. Yes, so if they are a bit apart, that energy, what do you think the boiling point will be compared to the the liquid compared to solid? Lower boiling point. Yes, yes, but still because the particles are far apart, they can easily vibrate. Okay, that is liquid. Okay, and you can see it has higher surface area. Now you come to know this concept when we do what about rate of reactions. The thing is, yes, if I have a chalk like this, basically chalk is calcium. Who know what chalk is? Chalk is calcium carbonate. Yes, calcium carbonate. If I react with hydrochloric acid, an acid, this electron is very vigorous. You see foam coming up, chalk coming up. Yes, chalk. Okay, and hydrochloric acid is liquid. Do you see? It's liquid. What do you think you'll have? You'll have calcium chloride. Sorry.
Calcium chloride plus carbon dioxide.
I'm coming.
Plus water.
It's calcium chloride plus CO2 plus H2O. Is this balance? And calcium chloride, is it correct to write like this? Huh, Ali?
No, the capital.
Why?
That 2 after 0.
Yes. After? Cl. That's what I want to hear. Okay? Cl2 in it. Because calcium is 2 plus in it. Yeah. And chlorine is 1 minus. So you need another chlorine. Okay? That's right. So is this equation balanced? Because whatever we do, we have to do the concept we have learned. This is 2 here, yes? Are they balanced? Calcium carbonate, yes?
Add 2 in front of the HCl. Add 2 in front of the HCl.
HCl, yes? You think so?
Yeah.
Mm-hmm.
And then I think there's pretty much balance. 3 oxygen.
Is it balanced? 2 oxygen, 3 oxygen. Yes, it's balanced, yes. It's balanced, yes. The reason why I put this reaction is this reaction will be very slow because we have a piece of chalk and there will be a lot of reactant because the acid will have only the surface area here in it. It cannot get inside. You understand? So the reaction will not be efficient, one, because of less of the product will be formed. It will not be quicker because the acid will not get inside it. But imagine we put the chalk, we pound the chalk into small pieces in it. What will happen to the rate of reaction? It will increase, yes? But imagine also it is water now. The reaction will even be more vigorous in it. Yes. will be more vigorous.
But that nothing happens when you pop.
Yes? Yeah. It pop, it depends. Okay? So that is what we mean by liquid, being liquid, yes? There's now the other one is gas. The last one is gas. Gas, the particles will be like this. Let's say this is a container, because gas, if you put it in the atmosphere, there will be, you won't even control anything. Okay? Wherever you pull a gas, it will fill the container, yes? Particles are far apart. Okay? The particles are far apart. The particles are far apart. Meaning one is here, one is there. Even in the room here, there's oxygen here, there's carbon dioxide here. Yes? But the particles are far apart, so there's constant vibration in it and constant movement in it. Yes. Constant movement in it. Constant movement. Who know about avocado constant? Avocado? Avocado theory. Okay?
6 times 10 to the 20.
And there's another one called this guy's theory. I've forgotten. He said gas will fill any space you put it in, any vessel you put it in. I forget. Pascal. It's Pascal. I'm not sure. I forgot that one. Yes. The theories of gas. Yes. The various avocado theory, or what is this British guy's name? Newton. It's Newton theory. Any vessel. Okay? That's it. We learn this, yes? If you put this amount of gas, yes? Let's say 50 centimeter cube of gas. Okay? Or decimeter cube, yes? Of gas in a container which has a volume of 100 centimeter cube. The gas will fill it in it. Yeah? So the pressure, that the number of particle concentration of it will be 50, 1 centimeter cube per 2 centimeter cube, so 2 liter, okay? Liter of the, let's say liter, this one. Okay? Now, if you put 50 in 50 centimeter cube container, what will happen? You are now putting you're not restricting the space the gas can move around in it. Yes? You are increasing the pressure inside the tube. Okay? Now, imagine you put 50 in 5 centimeter cube. Okay? Now, instead of a big one, you put all these 50 in a small test tube like this. What will happen?
High pressure.
Very, very high pressure. Even in this, it can break. Yeah? Yes? And when we do about volumes and concentration, we will know how much of this thing you have to, pressure you have to put in. Yeah? Yeah. So gas, the particles are in constant movement in it. The particles are in constant movement because of energy. Yes? Because of the high energy they have. Yes? High energy they have. The particles have high energy in it. Yes. So if more energy is even applied here, now it starts being even more bombardment on the surface. Yes? Yes. There's even more bombardment. Yes? So, you can see. Yes. Yeah. So these are the state of gases. So, as I said, I cannot do justice to these topics by online means. Yes? I can't do justice to them. Because there's a lot I could say here, but the time will not allow us, because the thing become very big. Okay? The video become very large. So, okay? I remember when I was in primary school, the teacher will ask one of the students to come and rub the blackboard. And it's a honor in it. And the teacher will always give it to the brilliant student in it. So he will stand in front of the class. Everyone will see. Some people, they go above the board in it. They go above the board in it. What does that mean? Yeah, they exaggerate. So he'll be roaming the blackboard, looking at the people at the back, you know, and moving from place to place. Here I am, and look, I'm this most capable guy here, you know. You know, there are people with different characters in it. Some people want to be noticed in the public. But the tickets they give is a brilliant student, you know. MashaAllah. You know? Okay. So let's go on. Mustafa, let's go on, please. Now, on the state of matter, we said changes in state. Changes in state. Changes in state. That meaning changing from this, okay, compressed particles, solid, to that. To this one. Okay, so from solid, this is solid, highly compressed, to liquid, to gas. Okay, now, for you to change from this to that, it means this, because the particles are far apart. To make this far apart, you have to apply heat or energy, yes? Heat or energy. And therefore, to change this to this is called what? The melting point. And for that of water is 100 degrees centigrade. We have seen the others minus, is it? Yes, especially gases. So gases has very low melting point. As I mentioned that before, yes? Gases have low, yes, low melting and boiling points in it. Because there are already the gases in it. Yes, but there are different types of gases, so they will have different boiling, melting points, yes? Now, this or that also, I should have a red pen, yes, also involve heating. Because when heating happens, you are giving energy to the particles in it. You are giving energy to the particles, yes? So if they have energy, even we said, we give a lot of these sweets to kids, or some kind of tonic drink, or energy drink to kids, you know, they become, what happened to them? Very, very active. And they said, some musicians, when they smoke marijuana, they become more active, yes? And nowadays, we have another drugs called LSD. Yeah? It can make you happy one time, and after that time, you become very depressed. Okay? Because you work with your brain. You know? You work with your brain. And sometimes it can lead to madness, and it can lead to liver failure. Because there are some kids, they take it and they die instantly. Okay? Because your liver cannot take it. All of this, but this one is called what point?
Boiling.
Yes, boiling point, yes? Boiling point, yes? When it boils, when water boils, it came into gas, yes? Water is called water vapor, in it. It's called water vapor. Vapor is gas. You can see the steam coming out, yes? Yeah, it can turn into water vapor. Solid will change into liquid when it is boiling, it will change into liquid. Okay, all of this involve the supply of energy. Yes, when you supply energy, what happens is the vibration of the particles. Okay, now the water, when we input water in a basin here, okay, we can see the water in a container. But when we put a lot of heat on the container, what happens? The container dries up. Where does the water go? It fills the hole. That's why we say the gas will fill any room it's put in. But the water, you put it in a container, it will take a several container. And you be inside the container, you can see it. The reason is the particles, although they are not close, they are far apart, not as close as that of a solid. That's why it is in a liquid form. But when you apply heat up to the boiling point, like water, the boiling point of water is how much? 100% Celsius. When you apply heat, you can see when your mom is cooking, you can see the water vapor come here. And the vapor is gas. And the gas will come to the room. It can fill the whole of the room, yes? Because the particles are in motion. In motion, because they have a lot of kinetic energy, a lot of energy being applied, so the particles spread. That is called the boiling point, okay? Now, what about gas? What about the reverse? That this one to that one. It's called what? Condensation, yes? Condensation. Okay? So that means high energy, you apply to the, it has high energy, you freeze it in it. You reduce the energy in it. Energy supply, reduce the temperature in it. Okay, all the same, reduce the heat in it. Yes. Now, example is, let's say we have a small apparatus here. Again, we have our coke here, because if not, it will rise up in it, and we apply heat. Okay. Okay, the heat, when it comes, we heat it, yes? So what happened? The water vapor will rise in it. Now let's say we have some water here, a condenser, okay? Condenser, okay? That, as it passes here, if there's water inside here, it will cool down in it. The vapor will turn back to what? Water again in it. Yes. Okay, it will drip, drip, drip to water. Yes? That's right. But if we let an outlet here, what will go out? The gas will go out in it. Yes, gas will go out. But if we don't, it is cooled down, like put inside another this tube or something else. As it goes down, happen, the kinetic energy will reduce, yes? It will become more compact now. Yes? It will turn into back to liquid, yes? So this turning of water to vapor, water is boiling in it. It boiling point. It's called condensation in it. It condensed back in it. Yes. So this is called the freezing point, isn't it? Freezing point. But the freezing point actually is here. Liquid turning to solid is called freezing. Yeah? Freezing point. And for water is 0 degrees centigrade for water. The temperature at which liquid freeze, water freezes back to solid, ice, okay, is 0 degrees centigrade, yes? So Celsius, yes? You can make it -1, -2 because it's hard. So like when you go to the ice areas in the Siberian area, the glass is so strong that it can even cut your body. Yes, it can even cut your body because the temperature is -100. So it's so strong, like if it is it's iron. Yes. Do you see? So you condense gas back to liquid. You freeze liquid back to solid. Yes. The other way around, you melt solid to liquid. Yes. So you boil liquid to gas. Okay. All depend on supply or reduction of energy in it. Yes. So this is the concept you need to know. Now you know some gases. Their boiling point may be -125 degrees centigrade. Okay, minus. Okay? So if this is the animal, if you want to freeze them, you have at least apply 25 degrees. If this is the boiling point, yes, you at least have to take it to this or that one, you may be 25 degrees, yes? So to freeze it, you may apply -25 degrees in it. Yes. So it's the opposite. You can see 0 to 100 in it. Okay? You apply 100 degrees in it. You want to turn it back to you apply 0 degrees in it. Yeah. Turn back to where it was. Yes? Just like clouds. Cloud is the cloud, when cloud form in the sky, what is it? It's water? Vapor. Okay? But when the sea or plants give out water vapor, it condenses into water vapor in it. Yes, when they form gas, because when plants manufacture, when they do photosynthesis, what do? They use carbon dioxide and sunlight and chlorophyll and convert it into starch. Use the right starch or glucose in it. Now at night, when they what happened? What gas do they release?
Oxygen.
They release oxygen. That's why under the plants during the day it is a bit cold in it. Because of the gas, oxygen is cold. At night they release carbon dioxide in it. Yes. No, at night. They breathe. When a person breathe, what do you breathe out?
Fire, carbon dioxide.
Yeah, you breathe in oxygen, you breathe out carbon dioxide, yes. So that carbon dioxide and water vapor goes up into the sky. That's why in the rainforest areas there is a lot of rain. Because there are a lot of condensation in it. Yes. Okay? That's right. So basically, this explains the state of matters. In the syllabus, let me look at it. Now the syllabus, I want to go according to the syllabus, okay? I want to go according to the syllabus. The syllabus has called particle theory, okay? Particle theory and bulk theory. This is syllabus 2A, okay? Bulk theory and equations, how the equations look at. This is the three topics left, yes? But in the same 2A, we have to deal with nanoparticles in it. Nanoparticles, yes? We have talked about nanoparticles before, but we have to talk about it now. Now, particle theory is what we just learned. That when particles gain energy, they vibrate in it. They become motional. They were in a static state, like in a solid. They were in a static state, like in a solid. Static state. But when they gain energy, they become motion in it. So that convert them into liquid. Okay? And the same apply to a gas because of the particle theory. It gain more energy and it convert into gas. This is what we mean by particle theory. That's the particles in a compound or in a substance will be a state of staticness. But once energy is applied, they become motional. Yes, they become motional. They vibrate. That is called particle theory. You can read it. Yes. Bulk theory means substances or solid are made of thousands and millions of particles. Yes. Okay. This is only one particle. Thousands and thousands of particles together. That's what you have. You just want to look with bulk. Yeah? In a bulk. Yes. Yes. So in that situation, you may have to have interactions between the particles in it. Yes. That is called bulk theory. The bulk theory says if you have a sample of substance, it contains billions of atoms or molecules. It has a bulk property such as density, melting point, which stay the same regardless of how many atoms or molecules you have in the sample. These properties depend on how the particles interact with each other, so a single atom or molecule will behave differently. Yes? That's what it's saying. Yes, you have a container of liquid, you have billions and billions of H2O molecules in it. Yes? You have billions and billions of H2O molecules. Or you have sodium chloride salt, you have billions of particles, sodium chloride, potassium iodide. Okay? Billions of yes? So, therefore, they will have very high melting and boiling points because you have billions of them. Okay? That doesn't mean if you make this half, you cut it into half, you have a different boiling and melting point. No. The boiling point will be standard. Do you get me? Yes. So there's a standard boiling point. That is about bulk concept, the concept of bulk concept. We have to do quickly because there's time for Salah. Now, what about the equations? Now, let's look at this. We can say hydrochloric acid plus calcium carbonate, okay? Will give you calcium chloride plus carbon dioxide plus H2O. Now look at the states. This could be liquid or aqueous, yes? It could aqueous. Aqueous means like in jelly forms, okay? Like in jelly forms, isn't it? But calcium carbonate is solid. That's why sometimes they put this on the side of the the compound here when you look at the equations. Yes? Calcium carbonate here is solid. Carbon dioxide is gas. It says, why do you have gas here? None of them is gas, but it produces a gas. You understand? And liquid in it. Water is liquid in it. Okay. So this could be liquid form, it can aqueous form, yes? But when they react, they can produce solid, gas, and liquid. And that's why if you look at the equations, yes, they put how we call it again? They put at the side note in two brackets the condition they are. Because this means that there's no water inside. Aqueous means there's no H2O. Okay? But if sodium chloride is dissolved in water, that means in that sodium chloride you will have sodium ions, chlorine ions, because we said when this ionic compound dissolve in water, they form ions in it. But the ions in that water will be sodium ions, chlorine ions, yes, hydrogen ions, and OH minus ions. So if they ask you what are the ions in a solution of sodium chloride, these ions you should say. Because water, we said, is hydrogen plus a hydroxide ion in it. Yes. Do you get it? Yes. Okay? But aqueous solution means there's no water. That's why if we do electrolysis with an aqueous sodium chloride, okay, normally liquid sodium chloride, okay, sodium chloride, liquid sodium chloride, we will have hydrogen gas. If this is positive, this is negative, hydrogen H plus, OH minus is there, okay? The H plus will go to the negative electrolyte in it. So, electrode, yes?
Opposite charge.
Electrode in it. So, hydrogen plus, yes, will gain one electron in it, okay? It becomes hydrogen atom, yes? If it is 2, it becomes hydrogen gas. 2 electrons in it. Yes. Do you understand? These are called half electron, yes? You can write it so many ways. You can say sodium atom lose an electron, it becomes sodium
Minus. Plus.
Sodium plus. Okay? But you can put the other way around. This is minus, put it the other way around. Sodium plus 1 electron, sodium atom in it. Sorry. Sodium atom. Sodium ion is an atom of sodium which has lost 1 electron. You add 1 electron, become back to sodium in it. This is called half reaction, yes? You do a lot of this when you do electrolysis, yes? And oxidation and reduction. This is what happened in the negative electrode. The hydrogen will gain electron and it becomes hydrogen gas. So if it is a tube, hydrogen gas will go off here. Okay? Then the sodium, then there will be sodium hydroxide left in the solution, yes? So this solution will turn into a base. Do you get me? But if it is an aqueous solution, that means only sodium chloride in it. There's no water. There's no water. You boil only salt until it becomes in liquid form. Like when you apply so much heat into iron, it becomes molten. Yes? So that's what it meant. Wrong. Aqueous means in water, in it. Okay? Molten means no water. I beg your pardon. Yes? If it's molten sodium, chlorine, instead of hydrogen coming out, chlorine gas will, yes, will be released. Because what happened is chlorine minus will gain an electron, let's say 2 electrons in this case, L2. Do you get it? Yeah. That's right. Chlorine ion, which is when this thing is molten. In a molten state, it means we say there are 3 states: solid, liquid, and in molten state, the atoms, the electrons or the ion will be in vibration. Yes, they try to snatch electrons to become an atom. Yes, that's what will happen. Chlorine will go to the positive anode in it. Sorry, chlorine will not come here. Chlorine will come out here because chlorine is negative. Yes, it will gain 2 electrons and become chlorine gas. Yes. So in electrolysis, the positive ion will go to the negative anode, and the negative ion will go to the positive cathode. Okay? That's right. Do you get this is what we mean, the state of the compound. Yes? Aqueous, solid, yes? Produce solid, gas, and liquid. Yes? This is the last part of this topic. MD, subhanallah, nadim, sallallahu ilaha illa anta, astaghfirullah. Now,